Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rule, or also known as the chain rule, in computing the derivative of this given composite function. The given function here can be written as a composite function. Let's say our f of x is x to the power of 6, and our g of x is 8x cubed minus 5x plus 10. This function that we are given here, let's just say this is h, okay, h of x. Okay, our f of x here is identified as h of g of x, since we substitute here this entire expression to the x of the h. That is why we have the form the sixth power of 8x cubed minus 5x plus 10 raised to the power of 6. Okay, again, this fits the criteria for composite function, and then we are going to use here the rule in differentiating composite function. If you have here in this case our f of x is, again, we have h of g of x, or identified as h of g of x. Okay, its first derivative is this. According to the chain rule, take the derivative of h, the composite function, treating this as 1 using this power, using the rule of, or differentiating the power of a function, times the derivative of g of x, which is this entirely. You could try a scratch here if you would like to. Let's have h prime of g of x, again treating them as 1 using only the rule of differentiating a power with this power here. So that is actually 6 times this expression, 8x cubed minus 5x plus 10, and then according to the rule of differentiating a power, n, that's 6 minus 1, which will give us a result of 6 times this minus 5x plus 10 raised to the power of 5. Take note, do not distribute this because this is under an exponentiation. You can just stick to that as it is. And then for your g of x here, g prime of x, only this function, or this original function here, take its derivative. So actually you will have this here. So you will be using here the rule in constant multiple, the rule of the sum or difference. You have 8 times 3x3 minus 1 minus 5x 1 minus 1, and the derivative of a constant, which is 0. Hence you will have here 24x squared minus 5, because x to the power of 0 is just equal to 1. With this now in mind, using again this for the derivative of a composite function using the chain rule, so I'm rewriting it here, times the derivative of g. So you will have this final form, 6 times 8x cubed minus 5x plus 10 raised to the power of 5, times you will have here 24x squared minus 5. Simply rearranging them, you can have here 6 times 24x squared minus 5, then you will have here 8x cubed, because multiplication is commutative, minus 5x plus 10 raised to the power of 5. Now, for some, they would like to multiply this, you can, and you will get here, I believe, 144x squared minus 30, but of course, you can just simply stick to this as this r, and this is the result for the differentiation or derivative of this given function that can be expressed as a composite function. Thank you very much for watching. So what are you waiting for? Subscribe now.